Section 350.56 of the National Electrical Code, specifically from the 1998 edition, addresses the permitted uses of flexible metal conduit, commonly referred to as FMC. This section explicitly states that FMC is not permitted for use underground or embedded in poured concrete or aggregate. The underlying reason for this prohibition lies in the inherent limitations of FMC in such environments. FMC is not designed to withstand the detrimental effects of moisture, corrosion, or physical damage that are commonly encountered when buried underground or encased in concrete. In such conditions, FMC is highly susceptible to degradation, which can compromise its electrical integrity and pose significant safety hazards. Considering the specific project, the electrical contractor's approach of notching the face shell of a concrete masonry wall and dry packing FMC into it raises concerns. While the code doesn't explicitly forbid FMC within a concrete masonry wall, the potential risks associated with this type of installation must be carefully evaluated. Firstly, concrete masonry walls have the characteristic of absorbing moisture. This moisture can readily penetrate the wall structure and come into contact with the FMC. Over time, this exposure to moisture can lead to corrosion of the FMC, potentially compromising its structural integrity and electrical conductivity. Secondly, the method of dry packing the FMC into the face shell may not offer adequate protection against physical damage. The FMC could be vulnerable to impacts or movements within the wall, increasing the risk of damage to the conduit and the conductors inside. Given these concerns, it's highly recommended to seek the expertise of a qualified electrician. A qualified electrician can thoroughly assess the specific installation, taking into account the environmental conditions and potential risks. Based on their evaluation, they can provide recommendations for ensuring the safety and code compliance of the electrical system. One potential solution that the electrician might suggest is replacing the FMC with a more suitable type of conduit, such as rigid metal conduit, RMC. RMC is specifically designed and approved for use in concrete masonry walls, as it offers superior protection against moisture, corrosion, and physical damage. To further elaborate on the NEC Section 350.56, it is important to understand the implications of burying FMC underground. When FMC is buried directly in the earth, it is exposed to a variety of environmental factors that can accelerate its deterioration. These factors include moisture from the surrounding soil, corrosive chemicals, and physical stresses from soil movement. The combination of these factors can lead to rapid rusting, weakening, and eventual failure of the FMC. Similarly, encasing FMC in poured concrete or aggregate presents significant challenges. Concrete is a porous material that can absorb and retain moisture. This moisture can seep into the FMC, leading to corrosion and eventual failure. Additionally, the weight of the concrete can place stress on the FMC, potentially causing it to deform or collapse. Furthermore, the alkaline nature of concrete can react with the metal in the FMC, accelerating the corrosion process. In the specific scenario of notching the face shell of a concrete masonry wall and dry packing FMC into it, several additional considerations come into play. Firstly, the face shell of a concrete masonry wall is typically not designed to accommodate electrical conduit. Notching the face shell can weaken the wall's structural integrity, especially if the notches are too deep or too closely spaced. This weakening can compromise the wall's ability to withstand loads and resist lateral forces. Secondly, dry packing the FMC into the face shell may not provide adequate support and protection for the conduit. The dry pack material may not be dense enough to prevent the FMC from moving or vibrating, which can lead to chafing and damage to the conductors inside. Additionally, the dry pack material may not be able to prevent moisture from seeping into the face shell and corroding the FMC. Thirdly, the location of the FMC within the face shell can also be a factor. If the FMC is located near the exterior surface of the wall, it will be more exposed to moisture and temperature fluctuations. This can accelerate the corrosion process and increase the risk of damage to the conduit. In addition to the concerns about moisture, corrosion, and physical damage, there are also concerns about the potential for electrical hazards. If the FMC becomes damaged or corroded, it can create a path for electrical current to leak to ground. This can result in electrical shocks, fires, and other safety hazards. To prevent these hazards, it is essential to ensure that the electrical system is properly grounded and that all electrical components are installed in accordance with the NEC. In light of these considerations, it is important to explore alternative wiring methods that are better suited for use in concrete masonry walls. One such alternative is rigid metal conduit (RMC), as mentioned earlier. RMC is a heavy-duty conduit that is designed to withstand the harsh conditions encountered in concrete and underground environments. RMC is typically made of steel or aluminum and is coated with a corrosion-resistant material. This makes RMC highly resistant to moisture, corrosion, and physical damage. Another alternative is electrical metallic tubing (EMT), which is a lightweight conduit that is often used in indoor applications. While the EMT is not as robust as RMC, it can be used in concrete masonry walls if it is properly installed and protected. To protect EMT from moisture and corrosion, it should be encased in a waterproof sealant or coating. Another option is to use non-metallic conduit, such as PVC conduit. PVC conduit is a lightweight, flexible conduit that is resistant to moisture and corrosion. PVC conduit is often used in underground applications, but it can also be used in concrete masonry walls if it is properly installed and supported. When selecting a wiring method for use in a concrete masonry wall, it is important to consider the specific environmental conditions and the potential risks. The wiring method should be able to withstand the moisture, corrosion, and physical damage that may be encountered in the wall. It should also be installed in accordance with the NEC and other applicable codes and standards. In addition to selecting the appropriate wiring method, it is also important to ensure that the electrical system is properly grounded. Grounding provides a path for electrical current to flow safely to ground in the event of a fault. This can help to prevent electrical shocks, fires, and other safety hazards. The NEC specifies the requirements for grounding electrical systems. It is important to follow these requirements carefully to ensure that the electrical system is properly grounded. Another important consideration is the selection of appropriate electrical boxes and fittings. Electrical boxes and fittings are used to protect electrical connections and to provide a safe enclosure for electrical components. The electrical boxes and fittings should be suitable for the environment in which they are installed. For example, electrical boxes and fittings that are used in damp or wet locations should be watertight. The NEC also specifies the requirements for electrical boxes and fittings. It is important to follow these requirements carefully to ensure that the electrical connections are properly protected. In summary, the installation of FMC in the face shell of a concrete masonry wall raises several concerns about moisture, corrosion, and physical damage. While the NEC does not explicitly prohibit this type of installation, it is important to consider the potential risks and to take appropriate measures to mitigate them. Consulting with a qualified electrician is essential to evaluate the safety and compliance of the installation. The electrician may recommend replacing the FMC with a more suitable type of conduit, such as RMC, or taking other measures to protect the FMC from moisture and corrosion. It is also important to ensure that the electrical system is properly grounded and that all electrical components are installed in accordance with the NEC and other applicable codes and standards. Beyond the specific concerns related to FMC in concrete masonry walls, it's beneficial to broaden the understanding of conduit selection and installation practices in various environments. The NEC provides detailed guidelines for choosing the right type of conduit for different applications. For instance, when running conduit underground, factors such as soil conditions, moisture levels, and potential for physical damage must be considered. In corrosive environments such as industrial facilities or coastal areas, special types of conduit with enhanced corrosion resistance are required. Similarly, in hazardous locations such as areas with flammable gases or dust, explosion-proof conduit and fittings are necessary to prevent explosions. The NEC also specifies the requirements for supporting and securing conduit. Conduit must be properly supported to prevent it from sagging, swaying, or becoming damaged. The spacing between supports depends on the type of conduit and the size of the conductors it contains. Conduit must also be securely fastened to walls, ceilings, or other structures to prevent it from coming loose. In addition to the NEC, there are other codes and standards that may apply to conduit installations. For example, the National Electrical Manufacturers Association (NEMA) publishes standards for conduit and fittings. These standards provide detailed specifications for the design, manufacture, and testing of conduit and fittings. Local building codes may also have specific requirements for conduit installations. It is important to consult with the local building department to determine the applicable codes and standards. When installing conduit, it is important to follow the manufacturer's instructions carefully. The manufacturer's instructions provide detailed information about the proper installation techniques for the specific type of conduit being used. Failure to follow the manufacturer's instructions can result in improper installation, which can compromise the safety and performance of the electrical system. It is also important to use the right tools for the job. Installing conduit requires specialized tools, such as conduit benders, threaders, and cutters. Using the wrong tools can damage the conduit or make it difficult to install properly. Finally, it is important to inspect the conduit installation after it is complete. The inspection should verify that the conduit is properly supported, secured, and grounded. The inspection should also check for any signs of damage or corrosion. If any problems are found, they should be corrected immediately. In conclusion, the proper selection and installation of conduit is essential for ensuring the safety and reliability of electrical systems. The NEC provides detailed guidelines for choosing the right type of conduit for different applications. It is important to follow these guidelines carefully to ensure that the electrical system is properly protected. The NEC is updated regularly to reflect changes in technology and safety practices. It is important to stay up to date on the latest edition of the NEC to ensure that electrical installations are in compliance with the current codes and standards. The National Fire Protection Association (NFPA) publishes the NEC. The NFPA is a non-profit organization that develops and publishes codes and standards related to fire safety and electrical safety. The NEC is widely adopted by state and local governments in the United States and around the world. It is also used by insurance companies, electrical contractors, and other professionals in the electrical industry. The NEC is a comprehensive document that covers a wide range of electrical topics, including wiring methods, grounding, overcurrent protection, and equipment installation. The NEC is organized into chapters, articles, and sections. Each section of the NEC contains specific requirements for electrical installations. The NEC is a complex document, and it can be difficult to understand all of the requirements. However, it is important to make an effort to understand the NEC to ensure that electrical installations are safe and in compliance with the current codes and standards. There are many resources available to help people understand the NEC. The NFPA offers training courses and publications on the NEC. There are also many websites and online forums that provide information and support for electrical professionals. Electrical contractors and other professionals in the electrical industry should make use of these resources to stay up to date on the latest edition of the NEC and to ensure that their electrical installations are safe and in compliance with the current codes and standards. The NEC is not a static document. It is updated regularly to reflect changes in technology and safety practices. The NFPA publishes a new edition of the NEC every 3 years. It is important to stay up to date on the latest edition of the NEC to ensure that electrical installations are in compliance with the current codes and standards. The NEC is an essential tool for ensuring the safety and reliability of electrical systems. By following the NEC, electrical contractors and other professionals in the electrical industry can help to prevent electrical shocks, fires, and other safety hazards. The NEC is a valuable resource for anyone who is involved in the design, installation, or maintenance of electrical systems.